All right. Hi everyone. This is Jeff Z. In this video I want to share my learning experience of the LeetCode problem 69, the square root of x. So it's an easy problem, but there's lots of tricks in that. I will talk about this and um, also I will share like my thought process of how I actually get there to get the solution and where are the mistakes I made. So let's get into the description of the problem. So implement the square root. So the input is an int and it returns an int. So compute and return the square root of x, where x is guaranteed to be a non-negative integer, right? So since the return type is an integer, the decimal digits are truncated and only integer part of the result will be returned. So to give an example, the input is 4, square root is 2, no problem. And this input is 8. Example 2, the input is 8. The output is 2. Basically, the actual square root of 8 is actually 2.82842. But since we need to truncate the decimal part, so the 2 will be returned. Only the 2 will be returned, which is this part. All right, so it sounds pretty easy, but to me, I am a ordinary person, so I made a lot of mistakes. First thing, I tried a brute force solution, which is looping from 1 to x, actually looping from 0 to x. Um, it's feasible, it's working, but I mean logically it's working, but it would because you may take really long time to get to x if the x is a really big number. So it will get time limit exceeded if you submit the solution. So I made the first mistake. And the second one, I looked into the solution. I think binary search would be working. How this binary search works is like you just cut into half 0 to x. You just find the midpoint and see if the midpoint is square is actually larger than x or not. If not, then uh, depends on if it's uh, if it's larger, then you need to go back to cut the first half into another half. Um, so I tried to work on the solution, binary search solution myself first, but it failed on other test cases. The example actually worked, so I hit this run code, it worked, but not pass for all the test cases. I actually looked into why it's failed on other test cases. What I found is I used this kind of comparison. Say, if the mid multiply mid is actually larger than x or not. The problem is if x is a pretty large number, let's say the max value of the integer, and you use the mid, which is half of this integer, the max value. Uh, if you do, uh, if you have this product of this of the mid, what you will get is a huge number, and you will not be able to. It will be overflow, and you will not be able to um, compare these two numbers. Um, Instead, I checked the solution. It's using this trick, uh, which you can say if the mid is larger than x divided by mid. So in this case, you make sure that no matter the right side or left side, they are not overflow. So this is the trick that I learned. So I hope you guys will not make the same mistake as I did. Similar to this one as well. So this is another trick is I originally thought we should compare, is it larger, is it smaller, is it equal, because sometimes it will be equal, right? Let's say for the square, if in this case, uh, if we hit 2, and if we try say 2 multiply 2, is it 4? Yes, then we need to return. But actually you don't have to do that, because you just need to verify, is the mid multiply mid larger than, sorry, the mid is larger than x divided by mid, and also if the mid plus 1 is larger than x divided by mid plus 1. So you will understand what I mean in the um, in the code. So let's go through the code. The code is actually pretty simple. Yeah, so you'll see that if x is equal or smaller than 1, then just return the x, which means it could be 1, it could be 0, which pretty much saying that 1, the answer is the x itself. Then we'll basically define the left of the binary search, kind of the boundary of the binary search, and the right of the boundary of the binary search. So in this case, I use the standard solution is using integer dot max value, but I think we can also use the x, because we know um, it will, I mean, usually it shouldn't be the case that you need to check like a very large number, even larger than x. Um, and then in this case, uh, you just do a while loop, and uh, here we'll say that we want to find the midpoint, which is the left plus the right minus left divided by 2. So this is also a trick. So I originally thought I can use left plus right multiplied by 2. It's the same. The answer, ideally it's the same, but the problem is mathematically it's the same. But the problem is if the left and the right becomes super huge. Let's say in this case, left is 1 and right is the maximum value of the integer. It will be pretty much overflow as well. So in this case, using this trick, say right minus left divided by 2, it's guaranteed it will not, plus left, it will not be exceed this number, the max value of the integer. Okay, then it's basically in the comparison. So we find the midpoint. In this case, if we go back to 8, the midpoint is 4 in this case, and then we say we will need to compare, say, is the 4 larger than 8 divided by 4? For sure it's actually 2, right? It's basically larger than, the mid is larger than the answer, the right side. So in this case, you need to actually move the left boundary to the left. Sorry, the right boundary to the left, and then in this case, the right will become 3 in this case, right? And then we will actually do one thing is we'll loop again, um, and then get the mid, which the mid is in this case will be the left is 1, right is 2, right is 3, and the mid would be 2. And then we will do the same. Is the 2 larger than 8 divided by 2? It's not, so it will go to the else. So in the else, actually, this is another trick that you did, is we don't have to worry about equal or not. We just say, is this 3 larger than 8 divided by 3? mid is actually right now is 2, right? So it will say 3, which is true. Then we will return the mid directly. So in this case, we will say is is the is the current number larger than uh, sorry, equal or smaller than um, the the division, sorry, the answer of the division. If it is, we'll just see what's the next number's result. If it's larger, sorry, the left side is larger than the right side, which means that this is actually kind of the peak of the mountain, right? So, sorry, this is the boundary that we need to find, because in this case, 2 is uh, sorry, the square of this 2 is actually is smaller than 8, but 3, if we use 3, the product will be actually larger than 8. So this is the boundary, so we need to return the mid directly. It's gonna work the same for if the x is 4, because 2 is the product of 2 is not larger, is the same as 4, but then if we do 3, the product of 3 is actually larger than 4, which is gonna make this mid returned directly. So the time complexity of this solution is actually O log n, uh, because we are using the binary search solution. Um, and also because we don't introduce any new uh, variables. I mean, this is like constant variables, constant space variables. In this case, the space complexity will be O1. Um, hope you can learn all these tricks and what I mentioned in the problem, and learn from my experience. Hope this video is going to be helpful to you. Thank you for watching. See you next time.